In this slide deck, I want to talk about group functions, sometimes called aggregate functions. So these are a little different than row-based functions, which apply only to single values within rows. Right now, we're grouping things together, right? So they're aggregate or group, or sometimes people call them categorization type functions, right? We're going to have to talk about both the group by and the having clause now in order to use these. So this is where the group by and the having clause come in when we're doing group functions. So I'll talk about some of the basic ones first. So distinct will only return distinct values. Notice this one's a little bit different. In most database engines, distinct is not going to have a parenthetical. You're not going to put parentheses for your argument. You're just going to say, show me all the distinct values for a particular column. And you can list a bunch of columns, and it'll find whatever's distinct about that group of columns, right? So in this example, if I'm going to show distinct publishers, then I'm only going to get a list of the publishers in my database. As another example, let's say I wanted to get the sum of everything in my database, right? Or the sum of all of the costs, right? So if I do select sum costs, it's going to take all the costs and it's going to sum them. I'm going to get a single value, right? That's what makes this a group function. When I run that statement, I'm not getting a record for each row. It's going to take all the rows and combine them to give me that sum. So I get one result from that query, not 10 or 12 results for all of my books in my little database that I have here in my example. I could also subtract retail and cost, right? And then get the sum, which becomes the profit, right? So I can calculate what the profit is for all of these books. So first, for each row, it's going to sum the retail and the cost, right? So it's going to subtract the retail and the cost first from all of the rows. And then when it's all done, it's going to sum the result of that. So each row, it gets the result of retail minus cost, and then it sums everything and gives me the profit across all of these books. So if I sold one copy of each of these books, my profit would be $914, which is why Pearson makes so much money, right? You guys know that because you probably buy textbooks. As another example, I can show the average cost, right? So average just gives me the cost of all of my, what's the average cost of all of these books? How much does it cost the publisher, in other words? And then I could take the retail minus the cost, just like I did before, right? It's going to subtract all these. It's going to tell you that the average profit of each of these books is $117. So on average, we're making $117.97 on most of the books that we sell, right? So that's an example of using average or AVG. And again, most database engines have all of these basic group functions. You can also get the minimum, right? So in this case, it'll return 25 cents is the minimum cost for my old US Navy basic electronics book that I have laying around. The maximum, so most expensive book I had on my shelf when I put this together was an old Transistor electronics book I still have that was 185 retail when I bought it. So that would be the maximum, and I could also do the maximum from the average, right? I can nest these different these different queries, right? Let me go back. So I can nest. I can say find the average retail minus cost, right? So subtract cost from retail, get me the average, and then find the maximum, right? And it tells me that Transistor Electronics as the is the maximum of the cost. So I could also get a count of all of the records in my table, right? So select count star, just says count everything up. So I have 7 records all together. If I do count star, comma, publisher, because I have that extra column in there, the database engine's not going to know what to do. It's going to return an error. In Oracle, it'll look something like that. In MariaDB, it'll be something else. In MySQL, something else. They all have their own error message, but they're basically going to tell you the same thing, that you can't combine both a single row and a group function in the same query. You have to pick one or the other, right? Or you have to use a group by that tells it how to group the count. You have to say count what? I can't just count all my records and then also give you a list of publishers. Those are 2 different queries. But what we can do is count the number that we have for each publisher and then display the count for each publisher. So in this example, I have 3 Pearsons in my database. So Pearson's going to show up with a count of 3, and all the rest are going to have a count of 1. So that's what my group by does. So a group by. So anytime you have multiple parameters in your select statement with a group function, you must have a group by for all of the parameters that are not grouped. So you have to have that group by in order for that to work. So that works, right? Like we said, and you can do this with lots of different queries, right? So, or different functions. So, for example, average, right? Now I'm showing the average retail minus cost for each publisher. And then what that's going to reveal is that Pearson, or I'm sorry, Goodhart Wilcox, whoever that is, has the highest profit, right? They sell their books at the highest profit according to this. And I just made up these numbers, by the way. Who knows which one of these are more profitable? I'm sure it's a closely guarded secret. So I just made up their costs. I made them ridiculously low because I theorized that maybe the publishers have very low costs when they print the book. But in any event, I'm using that group by clause to try to figure out, what the average profit is for each one of these publishers for all of their titles. But I could also say filter out of this list anyone who's not making a profit, right? So this old paperback I have from the U.S. Navy obviously doesn't have profit, so I'm going to filter that out of my list. That's where I'm going to use the having clause. So normally you have a where condition, but with a group function, you use the having clause instead of a where clause. So you don't say where the average retail cost is greater than 0. You have to say having an average retail cost. So having is always with a group function. So if I add that to my query where that's greater than 0, it's going to filter out that U.S. Navy is the publisher, and then I get this shorter list of publishers that are actually turning a profit. All right, so nesting, we can nest. So for example, if I select the average retail cost from my books, the average title is $116.71. And then I could group that by publisher, right? So in other words, what I'm doing here is I'm saying, get me the average the average profit, but group it by the publisher and then give me the answer. So now my answer is 155.62 because what it's doing is giving me the average by publisher. So it's calculating the average for Pearson first, and then coming up with an average, which is 339.20, and then taking into account the rest of them and giving me an average across all the different publishers, as opposed to all the books. So now I'm saying what is the average profit by publisher, not by book, by adding that group by to that clause. So that's sort of nesting. Then you've got some interesting statistical functions in many database engines. For example, I've got a whole bunch of different values here for all the prices of my different books, right? And if I look at that, some of the pricing clusters around certain values, right? And I could kind of figure this out, right? So if we do a number line, our midpoint is $113.07. That's the mean of the cost of all of these books, or I'm sorry, the retail cost of these books. And then on the high side, maybe I've got 138, on the low side, 89. And then I could do some statistical analysis and I can see that the spread is 519.5. And that would be the variance, right? So that's how we calculate the variance between these different prices. And then from the variance, if you take the square root of the variance, you get the standard deviation. But instead of doing all that math manually, you could just use the standard deviation function, right? So if you just ask for a standard deviation, it'll give that to you. I don't want to talk about why this is important. It's just that, I think any of you that have done any kind of data analytics might know that there's different, all these different, you probably took a statistics class and learned about standard deviations and means and maxes and, all these other statistical terms. But just understand that in the database engine, a lot of the, we have functions that can support a lot of that statistical analysis. So some neat stuff you can do with that. So you don't have to write your own logic. You can, write your own algorithm to figure out, what the standard deviation is, like you had to do in your statistics class, right? Just like in statistics, one day they give you a calculator and you hit the standard deviation button and it does it for you automatically. The database engine will do this for you. And there are certainly functions to support that. Almost every major database engine has statistical functions as well. So those are some group functions that you can use. I just wanted to give you an idea of what that looks like.